In this video we're going to look at histograms and have a look at what they do, what they are, and how we can calculate problems from them. A histogram, okay, let's just write it up. Histogram is similar to a bar chart, but in terms of the height, it's not all about the height, it's about the area, and the area is proportional to the frequency. So what we do is we take a continuous scale along the bottom of class widths, and then what we do is represent the frequency by area. Now what we're going to do is look at some examples of this, and I'll graph some up, and then we'll look at answering some questions from them. Now what I've got here is the following. This is a typical table, and we'll put it on a graph. I think the best thing, let's go back now. The best thing for me to start working these out is to appreciate the following. Frequency density, FD, is the frequency divided by class width. Class width is going to be equal to, all we do is swap these over. So if you've done any rearranging of formulae, multiply it by the class width, divide down by the frequency density. So that's going to be frequency divided by frequency density. And then of course, frequency, if we just multiply both sides by the frequency density multiplied by class width. Now, if you can remember these, the rest is fairly straightforward because you can just work them around. Even if you can't remember them, if you remember one, you can rearrange to find the others. So what we've got here is frequency, and we've got the class width. The class width on this one is 10. Between 40 and it's 40 between 40 and 0, with 0 included, 40 not. The next one is 10, the next one is 10, the next one is 10, and the final one is 30. So they're unequal class widths. What we're going to do is draw this up as a histogram, and I'll get some axes on here. So along the y-axis we always have our frequency density, and along the bottom we have our classes. So that should work for that. And what I'm going to do is the following. I'm going to do 0 to 40, so that's going to be just here. So this is the here are your classes, and I'll just change the pen so you can see that a little better. So here's going to be 0 to 40. Here will be 40 to 50. This will be 50 to 60, 60 to 70, and then finally 70 to 100. And that will give us, has that got enough on? Have I done enough? No. I've done 0 to 30. Right, let's move from a long one. So 0 to 40 wanted, not 30. I was wondering why I come up with 9. Okay, and then that's going to be there, and we'll end up with that. So this one here we would write, and I'll write this one horizontally, would be 0, which is included, so the weight of whatever it was, chocolate bars or something, whatever goes there. Now this one is going to be 40 to 50, 40 is included, and the strict inequality excludes the 50. So this, I'd write that if I was able to write it vertically. 40, that's included, width, but in turn less than 50. And again, this one would be the 50 to 60 with the same notation. This would be the 60 to 70, same notation. And then finally the 70, which is included. So the weight is between 70 and 100, 100 excluded. This right here is the frequency density. How we do that is, remember, going back, frequency density, FD, frequency density is frequency divided by class width. So what we'll do, we'll work some out and we'll put it in this little box. So frequency is 5. 5 divided by 40, okay, 5 divided by 40 is 1/8, which is going to be 0.125. So 0.125, that is the frequency density. 6 divided by 10, class width is 10, that's 10 units, frequency is 6, 6 divided by 10, 0.6. 8 divided by 10, 0.8, 4 divided by 10, 0.4, and 2 divided by 30, which is going to give us, what's that going to give us, 1 over 15, which is going to be 0.06, something along those lines. So 1/15, 0.06 recurring. Yeah, so we'll call it 0.6 recurring, 0.06 recurring. Right, so if we look at our frequency density, we're going to do this up here. And this suggests now that I'm going to make my frequency density, we've got a maximum of 0.8. So if we call this one 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, so now frequency density is complete at the left hand side. All we have to do now is make the bars. So how I'm going to do this is, in fact, we'll do it with a shape. Let's do it with that one. We'll do it with this. So first one is 0.125, and remember this is now the frequency density, so I need it to be approximately, and it's going to be give or take about there. Okay, let's get that right there. Admittedly, that's not fantastic in terms of this end of it. Let's just make that look a bit more realistic. Okay, so it's going to be somewhere along those lines. In fact, this is just going to annoy me, so I'm going to do it. I'll do it with some straight lines instead. So if I do them with a black one, we're going to have approximately, it's going to be about there, and then we're going to drop it down to the line, and then there. So that's the first one, 0.125. The next one, 40 to 50, needs to be 0.6, which is going to be just there and just there. So now you can see that these bars are representative, so they're proportional to area rather than just being height related. And then we're going to have 0.8, which is going to be the 50 to 60. And I appreciate my accuracy isn't hugely impressive right now. But please, when you're doing it, take a bit more time. And then finally 0.006, which is going to be pretty small. So 0.06 is going to be somewhere just about, give or take, a bit about there. So there we go, there's our histogram. So here's class width and here's the frequency density, and we can work from that. So there's how to construct one. What we're now going to do is look at solving problems when we're given histograms. Here's the frequency density and here's the classes. So we can see unequal classes again. And what we're asked to do is find out how many leaves have less than 6 centimetres. So the key part here is what it's asking us to do. It's asking us now how many. How many means frequency. So automatically I go to my little formulae and say that frequency. Now, if we think frequency, we'll put more up. Frequency density is frequency divided by class width. Class width multiplied by frequency density is going to be frequency. And then finally, we're going to have the class width is going to be equal to frequency over frequency density. So which one are we going to use? Well, we want this one for frequency. So it's going to be class width, which is 4, multiplied by the frequency density. So the frequency density on the first part of the 2, we'll do it in 2 parts. 4 times by 1, that accounts for 4. That part just there. Now, 6 centimetres is just here. So now the class width is 2 and the frequency density is 2.5. So I've got 2 times by 2.5, which is going to be 5. And I'm using this, that one just there. Frequency is the class width times frequency density. So there are 9. How many leaves have length greater than 9 centimetres? So this is this one and then the next one to it. Class width is 1, frequency density is 2. So the answer is going to be 2 for that one. Now this one right here is 2 multiplied by 1, which is 2. So the class width is 2, the frequency density is 1, 2 times by 1 is 2. How many leaves did she measure? Well, let's look at this one. Class width is 1 and the frequency density is 4. 1 times 4 is 4. Class width is 2, frequency density is 3. 2 times 3 is going to be 6. So we add for 10 to these two and get 23. So this is why I think getting used to these can help, and then picking what you've got to do. Maybe perhaps don't find that helpful. I certainly like to have it up. Right. The age of each person in a coach party is illustrated in histogram below. We don't have frequency density this time, and we're told that there's 6 people in the 70 to 80 age range. So again, frequency density is equal to frequency divided by class width. Class width is equal to frequency over frequency density, and then frequency is the 2 multiplied CW FD. Now, if we think about it, what we've got here, the 70 to 80, that's this one right here. So what we can say is the information that we've got, if you look at what we're after now, we've got the frequency and we've got the class width. So frequency is equal to 6, class width is equal to 10. We want the FD, the frequency density. Well, frequency density, as we know, is frequency divided by class width. So frequency divided by class width is going to be 6 divided by 10, which is 0.6. So that's 0.6. From that, we can start building up the scale. So on here, let's build up the scale. So 0.6, 0.4, 0.2, 0.8, 1.0, 1.2, and so on and so forth. So how many people are there in the 45 to 50 age range? Well, this is the one just here, isn't it? So the class width, CW, is equal to 5. The FD now is 0.8. The frequency density is 0.8. So what do we want? We want the frequency. So frequency, remember, is class width multiplied by frequency density. 5 times by 0.8 is 4. So there are 4 people. That accounts for 4 people. How many people are in the 50 to 70 age range? So we've got 2 to deal with this time. This one is 15 by 1.2. So frequency density is 1.2, class width is 15. 15 times by 1.2 should give you 18. Yeah, that sounds right. And then this one, for 65 to 70, 5 wide and 1 high. 5 times 1, 5. So your answer is going to be 23. Now, that's about the lot of it. The only thing that now you may be asked to do is you'll be told that there were 5 people, and this wasn't included, I don't think, in the question. There were 5 people aged 20 to 30 complete the histogram. So what we want, we got 5 people, so the frequency is equal to 5 and the class width is equal to 10. So frequency density is going to be frequency divided by class width. 5 divided by 10 is going to be a half, or 0.5. So all we need to do to complete this is put this on. 0.5 is going to be somewhere just there, and then we just draw it in, and job done. So there we go. That's now a completed histogram. So that's pretty much a scope of what you're going to be asked to do. It's finding a relationship between one or the other. You may have a table, and I'll look at some more questions in a later video.